I started it over again. Notice the shapes that they're taking. If you really look closely at these, you will see that this looks like a sphere, the way it's pointing, okay? You will see that this goes up and down, and if you were to take a different view of these, you would see that these look like a dumbbell shape, like the p orbitals are, okay? I just thought this was pretty cool, so I thought I'd show it to you because, you know, because it's pretty cool. I mean, is there a better reason to show it to you than other than that? I think not. All right, so let's move on. Okay, so here's a chart. You should have seen it last year. Hopefully you remember it. The n equals 1 chart or level has one sublevel, and it's a 1s orbital, and it can hold 2 electrons. And I could read this chart for you, but I think that I don't need to do the whole thing. N equals 3 sublevels. It has a 3s, a 3p, a 3d. Okay. N equals 4 has 4 sublevels, 4s, 4p, 4d, 4f. Notice that the sublevel number is the number that I place in front of the energy, or the type of sublevel, okay, for each time. All right, and then this is just another one showing you what I showed you on that other diagram, which is that as you go down, okay, in energy level, so here's the n equals 1 level, here's the n equals 2, here's the n equals 3, the orbitals get larger and larger, okay? So an electron, I shouldn't say something, an electron that is in this orbital, okay, does not have nearly as much energy as an electron that's in this orbital. Because this electron, here's nucleus mom, this electron has the ability to stray way, way, way away from mom. This electron is held really, really close, okay? All right. We're almost done. We just need to go over this. Remember this little chart, okay, where we can pick out any spot that we want on the periodic table and write its electron configuration for it. So for instance, if I say, okay, oxygen is right here, oops, oh boy, whoopsie, sorry. If I say oxygen is right here, is oxygen right there? It is. I can say that its electron configuration is 1s, 1, 1s, 2. There's an electron here, there's an electron 2 here, so that would be 2s2. There's one here, one here, one here, one here, so it's 2p4. So if I were going to write the electron configuration for oxygen, I would write 1s2, 2s2, 2p4. You read it left to right, just like you read a book, okay? Now notice that we skip down. So if I were going to say I want the electron configuration for bromine, which is right here, okay, I would have my 1s1 and 1s2, and I would have my 2s2 and my 2p6, and I would have my 3s2 and my 3p6, that's a 6, even though you can't tell that it's a 6, and I would have my 4s2. But what we find out is that the 3D level actually has a higher energy than the 4P. So 3D gets put right here, and there are 10 of them. So 3D, 10, and 4P, 5. 5, yeah. And that is the electron configuration for bromine. Okay. We still need to talk about how we fit these electrons into their places. And I'm going